Good day, everyone. I am Daniel R. Sanson, and today we're going to learn something about the normal probability distribution. Now, what is a normal probability distribution? The normal probability distribution is a continuous distribution that has bell shape and determined by the mean and standard deviation. The normal distribution has a probability density function of 1 over sigma squared times the square root of 2 pi multiplied to e raised to negative 1/2 times the quantity of x minus mu over sigma quantity squared, where mu is the population mean, sigma is the population standard deviation, x is any score in the distribution or the values of interest, e approximately 2.718, and pi is approximately 3.1416. Now, when we talk about the normal distribution, it has its own characteristics. And number one, like what I mentioned earlier, a normal distribution has a bell shape and is symmetrical about its mean. It means both sides are equal. If the total area of this curve is 1, both sides has 0.5 and 0.5. Number 2, the mean, median, and mode are equal. It means the mean, median, and mode coincide at the center of the normal curve. Number 3, knowledge of the mean and standard deviation is necessary to identify a specific normal distribution. Number 4, each combination of the mean and a standard deviation specify a unique normal distribution. Number 5, the normal distribution extends indefinitely in either direction from the mean. The characteristics 3, 4, and 5 will be elaborated more of why the mean and standard deviation greatly affects the form and how the uniqueness of a normal distribution or of a normal curve. I will show it to you through video. Like what I said earlier, there are two factors that affect our normal curve. Those are the mean and the standard deviation. Why? For the mean, the change of value of the mean shifts the graph of the normal curve to the right or to the left. In this example, we use the function of our normal probability distribution, but here we denote our A to be our mean and B to be our standard deviation. Again, for the mean, the change of value of the mean shifts the graph of the normal curve to the right or to the left. Let's change the value of our mean. Let's say, let's increase it to 1, 2, 3, 4, 5, 6, 7, 8. As you can see, as we increase the value of our mean, it slides or shifts to the right. But when we decrease it to 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, it slides or shifts to the left. Thus, we can say that when the mean increases, it slides to the right. But when the mean decreases, it slides to the left. How about for our standard deviation? The standard deviation determines how wide, how thin the graph or the normal curve may look like. It will determine the height and the width of the curve or of the normal curve. When the standard deviation is large, the normal curve is short and wide. While the value of standard deviation, if it's small, it will yield the thinner or taller graph. Let's change the values of our standard deviation below. How about let's make it 1, 2, 3, 4. As you can see, as the standard deviation increases, our normal curve becomes wider and shorter. But when we decrease it to 3, 2, 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, our normal curve becomes taller and shorter. That's why our mean and standard deviation greatly affect our normal curve. To move on, number 6, the normal distribution is measured on a continuous scale, and the probability of a precise value is 0. And lastly, the probability that a random variable will have a value between any 2 points is equal to the area under the curve between those points. Now, how about when we convert the normal distribution to standard score? We have this so-called empirical rule. If the data values in a normal distribution are converted to standard score or the z-score, in a standard normal distribution, the empirical rule describes the percentage of the data that fall within specific numbers of standard deviation from the mean for the bell-shaped curves. The empirical rules allows researchers to calculate the probability of randomly obtaining a score from a normal distribution. To give you this empirical rule, the 68% of values are within one standard deviation. 68% of data falls within the first standard deviation from the mean. It means there is a 68% probability of randomly selecting the score between -1 and +1 standard deviation from the mean. How about the 95% of values are within 2 standard deviation? 95% of the values fall within 2 standard deviation from the mean. This means there is a 95% probability randomly selecting a score between -2 and +2 standard deviation from the mean. And lastly, if we have a 99.7% of values are within 3 standard deviation, it means 99.7 of standard deviation fall within 3 standard deviation from the mean. This means there is a 99.7 probability of randomly selecting a score of -3 to +3 standard deviation away from the mean. To give you the general definition of this empirical rule, the 68% probability area is equal to the probability of a 1 standard deviation subtracted or added from the mean. And for a 95% probability area or 95.45% probability area, it is the probability of subtracting and adding 2 standard deviation from the mean. And when we talk about the 99.7% probability area, it is the probability of adding and subtracting 3 standard deviation from the mean. To give you a clear picture about this empirical rule, let's validate this through these examples. Suppose we have these dog weights. What is the frequency and relative frequency of the dog weights that are within these values? First things first, we need to get our population mean. Since wala namang minention na random dito or sample, we assume that these are the population of the dogs. So we have 36 dogs here that weighs 2.24, 9.47, 6.11, and so on and so forth. So when we get the mean, we just get the total of the weights divided by the number of sample of dogs. So in this case, there are 36. So it will give us 6.11. And for the standard deviation, we just get the square root of our variance. It will give us 1.63. Again, these formulas are just reviews since you already watched this and were explained by our professors thoroughly. So I don't need to explain these things. Yeah, to move on. So what are the first thing that we need to do? What is the first thing that we need to do in finding the one standard deviation away, two standard deviation away from the mean, three standard deviation away from the mean, is to rearrange our data. When we rearrange our data, it should be from highest to lowest or vice versa, or from highest to lowest to highest. In this example, we arranged our weights from lowest to highest. So the highest weight is 9.47 and our lowest weight is 2.24. Now for the one standard deviation away from the mean, it has a frequency of 26. Since we will consider weight from 4.48 to 7.74. So let's see. To this value, we can see that 4.48, we will consider these values 4.69 to 7.35. Since we will be considering values within 4.48 and 7.74. So there are 26 values in between 4.48 to 7.64 or 72% relative frequency or 0.72 with a probability area of 68.27 since the empirical rule said so. Now, for the two standard deviation away from the mean. For the two standard deviation away from the mean, it has a frequency of 34. Since we will be considering values from 2.85 to 9.37. So in this table, let's just locate the numbers that between 2.85 and 9.37. So it means 2.93 to 9.01. These are the values within this range. Thus, it will give us a 34 of frequency or a 0.94 or a 94% relative frequency with an area of probability of 95.45 based on the empirical rule. And for the three standard deviation away from the mean, it gives us 36 or one relative frequency. Because right now, he will consider all the values since the range is 1.22 to 11. And it will give us an area of 99.73 probability area. For us to get a clear picture of this empirical rule, suppose we are to we are to compute the this problem. The scores of the JEC student in their statistics and probability quarterly examination are normally distributed with a mean of 35 and a standard deviation of 5. What percent of those scores are between 30 to 40? What scores fall within 95 of the distribution? So to answer, to give you the normal curve of this problem, since our mean is 35 and our standard deviation is 5, we will expect this kind of normal curve where 35 is in the middle since it's our mean. Since it has a standard deviation of 5, so it has a distance of 5 here. To answer the question number 1 or letter A, what percent of scores are between 30 to 40? So since 30 to 40 is here, so it will give us a 68.27%. How about to answer the question number letter B? What score fall within 95 of the distribution? So when we plot it, looks like this. So the scores between 25 to 45 falls under 95% of the distribution. Another example is To use the empirical rule to complete the following table, fill out the respective column or the range or interval of the scores based on the given parameters. But for the sake of illustration, I already fill out the table. Here we have a mean of 20 and a standard deviation of 2. To compute for the 68% probability area, we have an interval of 88 to 22. To compute for the 95%, we have 16 to 24. And to compute for the 99.7%, we have 14 to 26. You just need to substitute the values here. Substitute the mean here for the standard deviation here. The same goes with the 87 mean and 5.5 standard deviation. For the 68%, it will give you 81.5 to 92.5. For the 95%, it will give you 76 to 98. And for the 99.7%, it will give you the 70.5 to 100.5. As you can see, as the number of probability area increases, the range increases. All right. To give you the curve of these two examples, it looks like this. For the 68% with mean 20 and standard deviation 2, it looks like this. For the 95%, it looks like this. And for the 99.7%, it looks like this. And for the 68%, 95%, and 99.7%, with mean of 87 and standard deviation of 5, for the 68%, it will give you a curve like this. For the 95, a curve like this. And for the 99.7, a curve like this. Now, since we already mentioned about the z-score or the standard normal distribution, let's talk about, but before going any further, allow me to give you this note. Note that the normal distribution or Gaussian distribution, named after the Carl Friedrich Gauss, or we know that he formed the Gaussian distribution, is one of the most important probability distribution of a continuous random variable. The normal distribution is important in statistics and is often used in the natural and social sciences to represent a real valued random variables whose distribution are known. The normal distribution is sometimes informally called the bell curve. That's why it is represented by a bell curve. Now, since we already mentioned about the standard normal distribution, let's talk about converting a normally distributed random variable into a standard normal random variable. A z-score describes the position of the raw score in terms of its distance from the mean. When measured in standard deviation units, the z-score is positive if the value lies above the mean and negative if it lies below the mean. It is also known as standard score because it allows comparison of scores in different kinds of variables by standardizing the distribution. A normally shaped distributed area with mean of 0 and a standard deviation of 1, it will give us this figure. This figure represents that we have a mean of 0 and we have a standard deviation of 1 or a distance of 1. Now, what is the importance of z-score? Why do we need to convert our standard, our normal distribution to standard normal distribution, or what we call z-score? It is useful to standardize the values, raw scores of the normal distribution by converting it into z-scores because, number one, it allows researchers to calculate the probability of the score occurring within the standard normal distribution. And number two, it enables us to compare two scores that are from different samples, which may have different means and have different standard deviation. Now, to give you an example on how to compute this standard normal distribution or the z-score, first, allow me to give you the formula. The formula for a z-score is z equals to the ratio of the difference of x and mu and sigma squared, where z is the number of standard deviation from the mean, x, the value of interest, mu is the mean of the distribution, and sigma is the standard deviation of the distribution. We will denote x bar for mu if we are just getting it from sample, and s for standard deviation if we are just getting it from sample. How do you interpret z-score? This is we should know how to interpret the z-score because it's not enough for us to learn just how to compute it. We also need to learn on how to interpret our results. The value of the z-score tells you how many standard deviation you are away from the mean. If a z-score is equal to 0, it means it is on the mean. A positive z-score indicates our raw score is higher than the mean average. For example, if a z-score is equal to positive 1, it is 1 standard deviation above the mean. On the other hand, a negative z-score reveals the raw score that is below the mean average. For example, if a z-score is equal to 2, negative 2, it means that it is 2 standard deviation below the mean. To give you an example, let x be normally distributed with mean 72 and a standard deviation of 15. Now, when we find z-score corresponding to the values given below, and we should interpret it. So using the formula, if x or if the value of interest is 87, what is our z-score? It's 1, right? This means the value 87 is 1 standard deviation above the mean. How about if it's 59? So it will give us a z-score of negative 0.87. It means the value of 59 is 0.87 below the mean. 0.87 standard deviation below the mean. How about if the value is 72? And it will give us a z-score of 0. When the given x value is equal to the mean, the value of the z-score is exactly to 0. It means the value of interest and the population mean or the sample mean is equal. That's why it gives us a z-score of 0. For us to learn on how to use the z-table and how to use the Excel on how to compute and know if it's under if it's in our probability area or not, let's listen to Ma'am Najma as she will explain further on how to use the z-table and other tools for us to have a convenient learning while learning about the normal probability distribution. Thank you, everyone, and see you when I see you.